Hey guys, I wanted to work through the solutions to example 10b with you. We'll do it first directly in Cartesian, and then we'll switch it to cylindrical in the second solution. So when you set this thing up in Cartesian, you need to look at the solid that you're integrating over. And the instructions are slightly redundant. It says in the first octant, and so the key here is y squared plus z squared equals 9 is this cylinder running like this. Really, it goes all the way around and stretches, but we're just interested in the first octant. Y equals 3x is this plane stretched up along the z-axis like that, and it slices your cylinder, giving you this sort of solid that we get here. Z equals 0 is the bottom. This is coming from the intersection of this curve with z equals 0. You plug in z equals 0 and you get out y is plus or minus 3. So this is exactly y equals 3. There's my friend Jared chiming in. All right, so that's that. That's the solid that we're integrating over. So if I do this thing directly, there's really a natural order. And the natural order is to do x first. You want to go x from 0 out to this plane. You could also try and do z first. You could go z for 0 up to this surface. But this surface is going to involve a radical. So let's see what happens. I'm going to try it as x first. You can maybe try it the other way and see if you can get it to work. When I set this up, I'm going to say, all right, z, I'm going to do dx, and then the order that I ended up with was dz dy. X goes from 0 out to this plane. I have to solve that thing for x. So 0, the plane when I solve for x is just y over 3. And now what's happening? I'm looking at the shadow of this solid back in, man, I should have turned off my notifications, back in the YZ plane, and I get just this semicircle. So this solid here is the semicircle. Its equation, of course, is y squared plus z squared is 9. I'm going to solve for z, and I get z is plus or minus 9 minus y squared. I take the positive because I'm up here. If I was down here, I would take that negative radical. So z goes from 0 up to positive square root of 9 minus y squared. And of course, y, you can see, goes from 0 out to 3. So that's the setup in Cartesian. And when you actually go and work this thing out, it's really not too bad. You want to integrate z with respect to x. And so we're just going to get 0 to 3, 0 to square root of 9 minus y squared. Zx, I evaluate x from x equals 0 to x equals y over 3 dy. And so I end up with, when I plug everything in, I'm going to plug this in, and I'm going to get 0 to 3, 0 to square root of 9 minus y squared. I get a zy over 3. I'm going to put the over 3 outside as 1/3. Subtract, plug in 0, you 0 it out. So I just get a z times y dz dy. Okay. Now I'm going to integrate with respect to z. And when I do that, I'm going to get a z squared. And that's going to thankfully kill the radical there. Probably that would have worked whether you did dx first or dz first, but I wanted to try dx first. So I'm going to integrate this thing. I have 1/3, 0 to 3. Integral of z is z squared over 2. You could pop that 2 out if you want. You're going to plug in z equals 0, z equals square root of 9 minus y squared. You've got a dy left out here. And now you're going to, let's go ahead and pop the 2 out. So we're going to have a 6th, 0 to 3, square the square root, plugging that in, and I just get 9 minus y squared times y. Plug in 0, you 0 it out. So I'm sitting there. When I work out integrals, I don't like things to be factored. I don't like polynomials to be factored. So I'm going to have 1/6, 0 to 3, 9y minus y cubed dy. And I'm going to let you evaluate that on your own, but you should be able to come up with 27/8 without any problem. So that's one way to do this. You can do this just directly in Cartesian coordinates. I want to rewrite down, let's copy the problem in the picture as well. And I want to show you how you can use a modified version of cylindrical coordinates to solve this thing. So the modified cylindrical coordinates is I realize my symmetry is actually around the x-axis. And so because of that, I'm going to let x be what it wants, and I'm going to let z is going to play the role of r sine theta. Z is going to be my y. Y is going to play the role of x, so y is going to be r cosine theta, and x is just going to be x. And so it's not quite the cylindrical coordinates that we learned, but it's pretty easy to make that adaptation and to modify that. And so when we do that, let's see if we can set this thing up now. I'm going to drop this here. We go to set this thing up. So what's happening? So first off, I'm going to integrate this thing in the order dx, dr, d theta. Okay. And what's happening? Z is r sine theta. I have to kick out the other r, so I get a r squared sine theta. Fine. What is happening with my x bounds? So I say x is going, just like before, 0 to the plane. The plane here is x equals y over 3. So x goes from 0 to r cosine theta over 3. I'm in the quarter circle. This is radius 3. So r goes from 0 to 3. Theta goes from 0 to pi halves. That's the setup. How do we work this out? I'll do just a little bit more with you. So I'm going to integrate this thing with respect to x. And I get what? 0 to pi halves, 0 to 3, r squared sine theta x. Plug in x equals 0, x equals r cosine theta over 3, dr d theta. And so I end up with 0 to pi halves, 0 to 3, what do we get here? R cubed sine theta cosine theta. And then when you go to plug in 0, you zero everything out. And so we're sitting right there. R cubed sine theta cosine theta. This is a basic u substitution, so I would actually break this up. I would say this is the integral from 0 to 3 of r cubed dr times the integral 0 to pi halves of sine theta cosine theta. I forgot my third over here. Whoops. I had a 3 up here that I didn't write, so we need to put that outside, and we'll put it there. We'll put it there. There we go. And so, yeah. And then we're going to do u is sine theta, du is cosine theta, d theta. And so this all works out very nicely. You can check and you'll get the same thing. You should get, I believe it was 27 over 8. So that's how you do it. Ciao for now.